Hey everybody, so now what I will be doing is I will be taking up question 6. So let's start. So at first I will just read the question. The partial differential equation that, I'm not going to read it, sorry, is a three-dimensional wave equation. In the case of a spherical symmetry, for example, waves emanating from a point source, we can find a relatively simple form of the solution. Let r equals 2 square root of x squared plus y squared plus z squared, so that r represents the distance from a point x, y, and z in space to the origin. Show that the second partial derivative of u in respect to x, the second partial derivative of x in respect to u, plus the second partial derivative of y in respect to u, plus the second partial derivative of u in respect to z, equals to the second partial derivative of r squared over u squared plus 2r. Anyway, show that, okay? So first what I will do is I will draw a chain of dependence. So what is that chain in this case? And so for me, what I did is I noticed that there's this u there and then this r there. And so to make things easy for myself and easier for me to understand, what the chain that I made was u goes into r, goes into x, goes into y, goes into z. That's the chain that I did. So then what I'm going to do is I'm first going to analyze this first part, this one right over here. Okay. And so what is that? That is just saying that it is u, x, x. And so what is uxx? Well, uxx is the same thing as ux of x. And so to start taking that, we first need to find what u of x is. And so u of x is the same thing as u of r of x. And that's that. So now what we need to do is we need to take an x of that. So then we take equals, so this, let's move that up there. So let's do like this. So then this is equal to rx, x. Now what's important here is to not forget about the chain rule, because right here we have a chain rule. Not a chain rule. Well, we also have a chain rule, but also a product rule, because we have one derivative and another derivative. So then this is equal to ur x times rx plus ur rx x. So this one is simple because it's on the same level. So it's just going to be the second derivative of x. But over here, we need to start thinking about how to take this. So the way we can think about this is if we need to, we can create a substitution. So u of r is equal to w of r. So we're going to just plug that in. So then w of wx is then going to just be equal to wr times rx. So if we plug that back in, we're going to get w rx plus ur xx. So then over here we need to replace the w, so that means that it's going to be urr rx times rx, and then plus urxx. And now if we just simplify this a bit, and there's going to be two simplifications, but I mean by simplify is just this, so we can say urr times rx squared plus urrxx. So now what I'm going to do is I'm actually going to take and see what is rx actually, or what is the partial derivative. What is the partial of the r function in respect to x? So that means that I'm just going to write it over here. So rx is equal to, so if we take this in respect, it's going to be 1 over 2 root x squared plus y squared plus z squared times 2x, because we need to chain it to x squared. So these two are going to cancel out, and it's going to be x over root of x squared plus y squared plus z squared. So now what we need to do is we need to take the derivative again. So we're going to take, or in respect to x, so it's going to be Rx x, and that is equal to, so we're going to do the quotient rule. That's going to be root of x squared plus y squared plus z squared minus, sorry, okay, minus x times x over, because the derivative of this we just got, x squared plus y squared plus z squared over this all squared is x squared plus y squared plus z squared. So then if we simplify this a bit, what I'm going to do is I'm going to split this in two right over here. So we're going to get root of x squared plus y squared plus z squared over x squared plus y squared plus z squared minus x squared over root of x squared plus y squared plus z squared over x squared plus y squared plus z squared. Okay, hopefully that makes sense. And I know I kind of shifted it all up, down, you could say, over here, so I'll just shift this fraction back up. There you go. So it looks like they're actually in line. There you go. Okay. So now this one over here is actually just equal to 1 over square root of x squared plus y squared plus z squared. And then this one over here, if we look at the denominators and multiply them, it's literally just going to be minus x squared over x squared plus y squared plus z squared to the power of 3 over 2. Now what we can do is we can factor out the square root of x squared, or this whole thing over here. So square root of x squared plus y squared plus z squared. That's going to be equal to then 1 over x squared plus y squared plus z squared times 1 minus x squared over x squared plus y squared plus z squared. Okay? And so now when looking back at this equation, what we'll see is that it's going to be URR times Rx squared. So what is Rx squared? So it's going to be URR times Rx squared. And Rx squared is right over here. And that's just going to be x squared. It's not Rx squared, but if I'm squaring this over here, it's going to be x squared plus y squared plus z squared plus UR and Rxx is then 1 over square root of x squared plus y squared plus z squared times 1 minus x squared over x squared plus y squared plus z squared. Okay? So now that we have that, what we can also notice in a way is that all of these, because this function you could say is symmetrical, like symmetrical in terms of it doesn't matter if you're going to take x squared, the derivative of x squared or y squared or z squared, they're all going to be the same. So that means in the end, this is going to be identical to this one. So in respect to y, if we take the partial in respect to y or the partial in respect to z, they're all going to be the same. So then if we start adding them up, what we're going to see is, we're going to see that all like these terms are going to stay the same in essence, or they're almost going to be the same. There's going to be one small difference, and that is just instead of x squared over here, it's going to be, if we're taking it in respect to y, it's going to be y squared, and here it's going to be y squared, but the rest stays the same. So then what we're going to do, if we add all of them up, what we'll be able to do is we'll be able to factor out, because again, if I write all of it out, right, what's going to end up happening here, I'll write it out. So we're going to get URR squared, x squared plus y squared plus z squared plus UR 1 over root of x squared plus y squared plus z squared 1 minus x squared plus y squared plus z squared that I shouldn't have right next there. It should be a y squared plus URR z squared x squared plus y squared plus z squared plus UR 1 over root of x squared plus y squared plus z squared times 1 minus z squared over x squared minus y squared plus y squared plus z squared. And so what will happen here now is that we can group all of these terms. And again, I'm fancy. I can group all of these terms together by factoring out URR. And then I can even have a blue pen, and I can factor out, and I can group these terms together to factor UR and 1 over root of x squared plus y squared plus z squared. So over here. So let's do it. So what we will get then, let's go back to black, is going to be URR times, and if we just add x squared and y squared and z squared, maybe x squared plus y squared plus z squared over x squared plus y squared plus z squared. Some magic happening over here. Plus UR. And then we 1 over x squared plus y squared plus z squared is going to stay the same everywhere. So it's 1 over root of x squared plus y squared plus z squared. And over here, if we go, it's going to be 1 minus x squared plus y squared plus z squared plus 1 minus y squared x squared plus y squared plus z squared plus 1 minus z squared over x squared plus y squared plus z squared. There you go. So then this becomes 1. So it's going to be URR plus UR over 1 root of x squared plus y squared plus z squared. If we group all of this up, it's going to be 1, to be exact, 1 plus 1 plus 1, which is 3. 3 minus x squared plus y squared plus z squared over x squared plus y squared plus z squared. And this again looks falsy, it's good. So URR plus UR 1 over root x squared plus y squared plus z squared times 2. And now the really cool thing is that you could be saying, well, hey, we have a root of x squared plus y squared plus z squared. And if you remember the question, right over here, we're trying to prove that it's going to be 2 over r. But the trick here is to see that r is equal to root of x squared plus y squared plus z squared. So finally, we can go URR. And again, URR means the second partial derivative of r respect to u. So UR times, and this is 2, so it's going to be 2 over r. And bam, we got exactly what we needed. We proved that, we proved this. There, I'm not reading that again. Well, I didn't read it in the first place, but I'm not going to give you the pleasure of seeing me struggle to read that for another time. So now what we need to do is we need to go to the second part. And so the second part then, what does it say? By substituting star star into star, so by substituting basically, because this is the same, again, I get to use my fancy markers, red. So now we see that this over here is the same as this. So it's saying basically by subbing this into here, show that u of tr is equal to 1 r over r times f r minus ct, the solution where f is any arbitrary function. So then what we're going to do, I'm going to go back to black. I don't want to go too far from there. That's what I'm kind of hesitating. Sorry. Okay, I'm just going to copy it down and then we'll be able to here. I'll kind of rewrite it. So we have u of tr equals to 1 over r f r minus ct. And then the actual replacement that we did is that it's utt. Utt is equal to c squared times c squared times URR plus 2 over r ur. Over r ur. I could have literally read it from here. I'm a genius. I don't know how I was supposed to so much. 2r ur. Okay. So now what we can do is what we can see is that if we go utt, we can bring this over to the other side. So it's going to be utt minus c squared urr plus 2 over r ur equals to 0, right? So now the function that we have over here is 1 over r f r minus ct. So what we're going to do is we're going to look at our derivatives, actually, or partial derivatives to be exact. So ut is equal to 1 over r times, so because we don't really know the exact function of this, what we're just going to say is f prime r minus ct times negative c, because over here we're taking in terms of t. And then what we're going to do is if we take the second derivative then, so utt equal to 1 over r f double prime r minus ct. So then it's going to be times negative c, which is going to equal to c squared over r f double prime r minus ct. Now it's going to come to the bit more annoying part, slash harder part. Not hard, just annoying. Where it's just going to be u of r. So u of r, what we need to notice then is that over here we have a product rule. So if we take the product rule, it's going to be, first we need to take it in respect to 1 over r. So it's going to be negative 1 over r squared. So over here times f r minus ct. And then we're going to need to take the derivative of this. So that's going to be plus 1 over r times f r minus ct. And we do need to change it with the r inside, but because the derivative of r is just 1, we can kind of leave it. And if you want, we can just write it a bit more pretty by going 1 over r f r minus ct minus 1 over r squared times, I forgot a prime over here, so f prime is over here. Sorry, guys. R minus ct. There you go. Okay, now comes the even more annoying part. We need to take the second derivative of y. That is equal to, so this is what you guys are getting a sneak peek for the next question, but you all probably know it. I'm just gonna make some more space over here. Bam, coming back up. So equals to, so it's gonna be negative 1 over r squared times f prime r minus ct plus 1 over r f double prime r minus ct. Then over here, so it's minus, so then over here we're taking the derivative. It's gonna be the derivative of 1 over r2 is negative 2 r cubed f r minus ct plus 1 over r squared f prime r minus ct. So let's simplify this a bit. So negative 1 over r squared f prime r minus ct plus 1 over r f double prime r minus ct plus 2 over r3 f r minus ct minus 1 over r squared minus 1 over r squared f prime r minus ct. These two are going to be grouped. I'm just going to write that quickly one last time. So equals to 1 over r f double prime r minus ct minus 2 over r squared f single prime r minus ct plus 2 over r3 f r minus ct. Now comes the fun part of plugging it all back in and then suddenly realizing that for some reason something isn't adding up, but then still being happy because you do notice your mistake and it does add up. Let's go. So let's start plugging things in. So UTT. So for UTT, we are going to get 1 over r times f double prime. Okay, wait, I'm going to start. So there's a negative c there, which I didn't simplify. No, it's okay. I see what I did. So it's c squared. See, that's why you have to look over here. C squared over r minus ct minus c squared times urr. I'm just going to move all of this over so I have space. I'm going to be scrolling back and forth to see what I actually wrote. So urr is going to be equal to 1 over r f double prime. And you can already kind of see that things are going to cancel out. So this one will cancel out with this one. R minus ct minus 2 r squared f prime r minus ct plus 2 over r3 f r minus ct plus 2 over r times, move this over just a bit. Okay, hope that. Nope, let's move it over, guys. And yeah, no discrimination. There you go. 2 over r. So it's 1 over r f prime r minus ct minus 1 over r squared f r minus ct. There, bam, and bam. Okay, so now what I'm just going to do is I'm not going to open up all these brackets, but hopefully you see that when we pull this into here, it's going to become 2r cubed fr minus ct. So these two cancel out. When I do this goes into here, it's going to become 2r squared fr ct. So this cancel out. Finally, when I open up the brackets, this and this cancel out. So it's going to be equal to 0. And therefore, we actually showed what we wanted to show. The second part, that is a solution. It's a solution. And we showed that it's a solution because we showed that UTT is equal to this. So cool. What is it called? Cheer for question 7 coming soon. Hopefully it doesn't take me too long.